Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we are going to start talking about solving inequalities, guys. And inequalities are very much like equations, except they have an inequality symbol. And a lot of times people don't even know what that is, so let's just go through it. Equations use equal signs, hence equation, equal. Inequalities use inequality signs. Less than, greater than, less than or equal to. Please remember when it's less than or equal to, there is a possibility of it being equal as well. Greater than or equal to, again, please remember it's greater than or equal to, so it's a possibility of being equal. And then not equal to is just an equal sign with a slash through it. Those are the inequalities, okay? So whenever you see a number sentence with an inequality symbol in it, you're talking about an inequality. It is no longer considered an equation. Couple things that you want to remember or I want to capitalize on for you when dealing with word problems involving inequalities are the words at most and at least. At most means less than or equal to. For example, Morrow is at most 40 years old. That means that Mr. Morrow is 40 years old or less. So you would say M for Morrow is less than or equal to 40. At most means less than or equal to. Okay? I can fit at most 50 people into the dining room. That means 50 or less. At most means less than or equal to. At least is the reverse of that. And at least means greater than or equal to. For example, Mr. Morrow is at least 40. That means that he's 40 or older. So in this case, M for Morrow would be greater than or equal to 40. So at most, less than or equal to. At least, greater than or equal to. If you think about it, it's kind of reversed, right? You would think that at most it's going to be getting larger, but no, at most is less than or equal to. At least you would think it's getting smaller, but no, at least is greater than or equal to. So very, very important when you're working with this. Now, there are a few different ways, well not a few, two different ways to write the answers to inequalities. And this is extremely important, and you have to know how to read both types of inequality answers. So I'm going to show you, I'm going to teach you how to do it. The first one is called a set builder notation. And a set builder is the basic way of writing inequalities. Okay? This is what you guys have done pretty much your whole life. You just were probably never told that it was called a set builder. And a set builder is portrayed by, you have braces, the variable in question that you're solving for, a line which separates it. This is just telling you, hey, I'm going to talk to you about x. And then whatever, you can have x is less than whatever, 5 or whatever it is. That's set builder, okay? That is set builder notation. So it's pretty simple. Set builder is basically the answer that you get, but you have to put it into the fancy little notation. So if I told you to write each solution using set builder, well, I'm dealing with x, and in this case, x is less than 5. That's set builder. X is greater than or equal to negative 2. Well, I do my little brace. I'm dealing with the variable x, and x is greater than or equal to negative 2. That's set builder. X is greater than 3. Well, I put my brace. I'm dealing with the letter x. X is greater than 3. Close my brace, and there you go. So set builder is pretty darn simple. Once you find the answer to your inequality, you basically have it in set builder already. You put your brace, you define the letter that you are talking about, you put a straight line to separate that, and then this part right here, that's the meat of this meal here. That is the real solution, or solutions in this case. Okay? So that's set builder. Set builder is pretty simple. We will no longer be using set builder in our future here as Algebra 2 students. You will see it from time to time, but what we really need to learn today is called interval notation. An interval notation is a fancy way of writing inequality solutions. Here is how it works. When dealing with less than or greater than signs, you're going to use parentheses. When dealing with less than or equal to or greater than or equal to inequality signs, you're going to use brackets. You always use parentheses for positive or negative infinity. I'm going to show you what this all means, but those are things you have to memorize. If you're dealing with an infinity as part of your answer, it has to be in parentheses. If you're dealing with a less than or greater than, it's parentheses. If you're dealing with a less than or equal to or greater than or equal to, it is a bracket. Okay? Now, when using interval notation, remember that the format is always going to be the same. You're going to have the smaller value, comma, followed by the larger value. Always. Always. It's never going to change, my brothers. Never. So let's see how exactly this works, gentlemen. I have each of the following inequalities as solutions, and I want to write this in interval notation. I have found through my years that the best way to do this is to first actually graph it and then write the interval notation. Because you're going to notice, you're going to see real quick here, that when you graph it, you're basically writing it in interval notation already. So let me show you what I suggest you do. X is less than 5. I'm not very picky excuse me, with graphs. I must have a 0 to have a frame of reference. I must put the number that I'm working with, 5. But x is less than 5. So my x value is going to go to the left of this or to the right of 5? To the left. But I'm using a less than. So am I going to use a parenthesis or a bracket? Back in the day, you used open circle, right? That's gone. That's Mickey Mouse Town. And we are now getting in real math. So we're going to use a parenthesis. And then we're going to shade. You may have had teachers that told you shade above the graph. I do not want that. I want you to shade on the graph. Now, does everyone understand that graph part? Yes. If you understand the graph part, guys, you will easily understand the interval notation. Well, why would I go this way? Why would I go that way? I'm going less than. The value is less than. So I'm going to the left. It's less than 5. So why would I go this way? That's inaccurate. I'm not going to the right. I'm saying that the values of x here are less than 5. So I put a parenthesis around 5 because it's less than. If it was less than or equal to, I would put a bracket. So this is telling me, hey, it's anything less than 5. That's why from 5 I'm going, excuse me, to the left. Make sense? Sir? No, I don't think that's what he meant, but that's what you meant. Do you close the parenthesis on the other side? No, why would you do that? No, why would you do that? This is less than 5. It's going all the way to negative infinity forever to the left. So that being said, yes, sir? No, if you closed it, that would be something different. Like let's say this was 4, and it was between 4 and 5. Then you would close it. But that's not what's happening here, guys. I'm very proud of the questions. X is less than 5, guys. So it's any value to the left of 5. And I'm going to keep going to the left forever. Forever. And when I go to the left forever, I'm going to a magical place called negative infinity. So to write this as an interval notation, please remember you go small value to large value. So if I'm going to the negative forever, what's the smallest value that I'm going to get to? Negative infinity. So I'm going from negative infinity, that's the small value, all the way to 5. Do you see now how this graph relates to the interval notation very easily? Yes, sir. No, it would not be to 4 because it could be up to 5 but not including 5. So that means it could be 4.9999999. I'm not trying to be sarcastic. It's reality. I can go all the way up to 5, but it does not include 5. This parenthesis tells the reader, hey, reader, I can go all the way to 5, but not including 5. Does that make sense, my man? Thank you very much. Good question. Number 2, x is greater than or equal to negative 2. So let's graph it, because I find that graphing it makes it so much easier. Greater than or equal to, so I'm going to use a bracket, and I'm going to shade it to the right. And it's going to the right forever. It's going all the way to the right forever towards positive infinity. So to write this as interval notation, I'm going to have a bracket. I go from my small value, negative 2, to my large value, positive infinity. And I always have parentheses around infinity because I can never equal infinity. Infinity is a concept that goes on forever. There is no end to it. So I can never, ever, ever have brackets around parentheses. X is greater than 3. Okay? So let's make my graph. Here's my 0. Here's my 3. Greater than 3. Parentheses. And to the right. Forever. So, how would I write this in interval notation? Yes, sir, my brother. Parentheses, yeah. Yeah. Positive infinity. I went from my small value 3 to my larger value infinity. Beautiful job, son. Yes, sir, my brother. Come again? If x equals, then we don't have an inequality anymore. That's an equation. If I say x equals 3, there is no infinity because x equals 3. But in this case, sir, it's saying x is greater than 3. So that means it can be any value greater than 3. That means it can be 3.1 or 57 billion or 3.96 or 4.2 or 17.27. But if it equals 3, there is no graphing that. It just equals 3. Why am I graphing here then, Mr. Morrow? Because I'm showing the reader I'm going from 3 and I'm going larger than 3 forever. Any of these values are valid. Talk to me, my man. I thank you for your honesty. Sir. Not equal is very rarely used. And if it's not equal, there's no graph, right? Right? We'll get to that as we get a little bit more complex. Thank you, sir. Okay? Now, these are very simple right now. We're going to be getting into compound inequalities just in a couple days. And just to give you a heads up on that, in a compound inequality, you may get an answer that's something like this. X is, let's say, greater than negative 3, but less than 5. To graph this, here's my 0, here's my negative 3, here's my 5. X is greater than 3, parentheses, and I'm going to the right. However, x is also less than 5, parentheses, going to the left. So in this particular case, the valid x values are between negative 3 and 5. I would write this as interval notation, negative 3, comma 5. This tells the reader it's anything between negative 3 and 5, but not including negative 3 and not including 5. You had a question, my brother. Does that make sense, boys? Another type of compound inequality you can have, this is called an AND inequality. And we're going to go over this in much greater detail, but I'm just giving you a little heads up. There's also an OR inequality. And an OR has two potential answers. It's either or, right? So sometimes you'll have something like this. X is, let's say, less than negative 3, but greater than 5 in this case. Well, in this case, I have a 0, I have my negative 3, and I have my 5. You always read from the variable. Never from the number, from the variable. So this reads x is less than negative 3, parentheses to the left, and it reads or x is greater than 5, parentheses to the right. Who wants to take a shot at how you would write this inequality as interval notation? Yes, sir, my brother. Parentheses, negative infinity, yes, sir. Beautiful. Good, you're great, but hold on. Whenever you have two like this, you have to unify both of them. So you would go in union with, now parentheses, perfection, my brother. Excellent. Give me 1 second, please. Okay, sorry about that. So does everyone understand the concept of interval notation? Yes, no, maybe, kind of, sort of? Yes, sir.
How would you say that? I said and or.
This is an and, my man, because it's encapsulated in between. This is an or because it's either less than negative 3 or greater than 5, my brother. Thank you. Yes, sir. In union. The U means union because there are two possibilities. So it's either this guy or this guy. So you have to put them in union together. Great question, son. Thank you. Yes, sir. No, you never read from negative 3, my man. It's always from the variable. This is x is greater than negative 3. You always read from the variable. Always. Thank you, sir. Yes, sir. Sure. Why not? That's a great question, son. Thank you so much. What if I had something like this? X is, I don't know, let's do, I don't know, greater than or equal to negative 2, but less than 1. Okay. So we got 0, we got my negative 2, we got my 1. Bracket, x is greater than 2, than negative 2, but it's less than 1. So how would I write that in interval notation? Got it. It's right there in front of your face. Bracket negative 2, comma, 1 parentheses. Beautiful. Great question, son. Great question. Does that make sense, gentlemen? Promise? May I continue? Okay. So now, graphing inequalities, we already went over it, because in order to really properly do interval notation, you gotta graph them. So these are just kind of a repeat. I'm gonna go pretty quick on this one. X is less than 5. We know it goes 0, 5. This is less than 5, so parentheses to the left. Just for giggles, that would be negative infinity to 5 in interval notation. X is greater than or equal to negative 2. Here's my 0. Here's my negative 2. Greater than or equal to, bracket to the right. Interval notation would be bracket negative 2 to positive infinity. 3x is greater than 3. 0, here's my 3. Greater than is just a parenthesis. To the right, interval notation would be 3, comma, positive infinity. And x is less than negative 4. 0, negative 4. Less than, so parentheses to the left. And interval notation here would be negative infinity, comma, negative 4. Does that make sense, gentlemen? Any questions? This is the time to ask, guys. Yes, sir. Thank you, my brother. I don't understand what that means. I'm not trying to be sarcastic. Please give me an example. Okay, if I have 5x is greater than 3, I have not solved anything yet. What is the point of every equation? We've talked about this already. To get the variable alone, isolated. So I would have to divide by 5, my man. And then x would be greater than 3/5. And then here's 0. Here's 1. 3/5 is about right here. Opens parentheses to the right. And then interval notation would be 3/5 to positive infinity. That's an inequality we have to solve, and we're going to get there now. Yes, sir. Yes, yes, sir. You have to put the 0 on the 1 because I need a frame of reference. A lot of teachers make you do every single number. So I think I'm being very fair here. Sir. Yes, sir, my brother. You will not have 2 brackets if there's an infinity involved. No. But you will have 2 brackets if it's an and it's greater than or equal to or less than or equal to. Yeah. And we're going to get there on compound inequalities. Okay? Thank you so much, guys. I really appreciate the honesty. Any other questions before we continue, gentlemen? Okay. So now, the good news and the bad news. In order to solve inequalities, simply use the same procedures for solving equations. That's the good news and bad news. If you know how to work equations, this is a joke lesson. I mean, it's just ridiculous. It's just silly. If you don't know how to work with equations, this is going to become very difficult for you. The only exception, guys, the only exception is the following. Whenever you multiply or divide by a negative, not to a negative, but whenever you multiply or divide by a negative, bless you, you must flip the inequality signs. You must flip the inequality signs. But that is when you multiply or divide by a negative. I'm not trying to be sarcastic. I'm trying to drive this point home. It's not to a negative, but it's when you multiply or divide by a negative. That's when you flip the inequality sign. For example, here I want you to solve each of the following inequalities expressed in interval notation and then graph the solutions. Well, in this case, we use the same skills as equations. How do I get this x alone? Divide by -2. But listen to what we said. Divide by -2. So if I'm dividing by a negative, what do I do that inequality? Very good. So that's greater than 5. Let's graph it. Parentheses to the right. And then my interval notation, 5, positive infinity. Bada bing, bada boom. Done. Done. How about for number 2? What do you think we would do here first, gentlemen? Yes, sir. Why not? Let's subtract 5x to both sides because I want to get the x's together on one side. -3, and then I have a negative x. How do I solve for that x? Because I don't want to solve for negative x. I want to solve for x. Yes, sir, my brother. Very good, my man. You divide by -1. So this means this guy flips. So x is greater than 3. Please read from the variable always. So x is greater than 3. Open parentheses to the right. Interval notation, 3 to positive infinity. Number 3. How do I solve for y here, gentlemen? Divide by 6. Excellent, gentlemen. Do I flip the inequality, right? Very good. Because I did not divide by a negative. I'm dividing to a negative. So this is y is greater than -7. 0. Here's my -7. It's greater than, so parentheses to the right. And interval notation, -7 to positive infinity. How do I solve for number 4? Yes, sir. Yes, sir. Yes, sir. All 3 answers. You have to solve it. Then I want you to graph it. Then I want you to put an interval notation. Yes, sir. Okay, how do I solve number 4 here, guys? Very good. So I'm going to multiply by the reciprocal of negative 3/4. Very proud of you guys. But I'm dividing, very good, say change flip. But I'm dividing by a negative, so I've got to flip the inequality. The 4's cancel. Negative 1/5 times negative 3 is going to be positive 3/5. Here's my 0. Here's my 1. My 3/5 is about right here. And it's going to the right. And my interval notation, 3/5, comma, positive infinity. Does that make sense, brothers? Promise?
Yes.
Okay. Now we're getting to the good stuff. Now we're getting to the good equations, to the good inequalities. All right, what do I got to do here, guys? We got a multi-stepper here. Distribute, very good. I'm very proud of you, gentlemen. So 12x minus 24 plus 12 greater than 11x minus 13. Now what do I do, gentlemen? Combine like terms. Very, very good. 12x, negative 12 plus negative 24 plus 12 is negative 12 greater than 11x minus 13. Now I'm going to subtract 11x to both sides. Now x minus 12 is greater than negative 13. Add 12 to both sides. And x is greater than negative 1. My graph, 0, negative 1, parentheses, greater than to the right. Interval notation, negative 1 to positive infinity. Talk to me, my brothers. Talk to me, please. This is my job. This is what I love to do. Talk to me. Ask questions. Okay, I try. How about number 6, gentlemen? What do we do here? How did I teach you guys how to do this? And hold on, real quick. Let me take all of this and get out of the way a little bit. Common denominator, yeah, good. What do I do with that common denominator? And what is the common denominator here? Yeah, good job. So 15 times 4, guys, is 60 divided by 3 is 20x. Minus 15 times 2 is 30 divided by 3 is 10. Less than or equal to. 15 times 4 is 60 divided by 5 is 12x. Very good job, guys. And 15 times 3 is 45 divided by 5 is 9. Now what, gentlemen? Subtract the 12x. You guys are doing great, man. I'm really proud of you. And that's going to be 8x minus 10 is less than or equal to 9. Now, add 10 to both sides. Very good, gentlemen. So I've got 8x is less than or equal to 19. Then I divide by 8. Excellent, son. And x is less than or equal to 2 and 3/8. Now let's graph it. That's between 2 and 3. So between 2 and 3, it's about here. Shaded to the right. My interval notation, 2 and 3/8, comma, to plus infinity. I'm sorry, son? Oh, wow. Epic fail. Thank you, sir. Thank you for paying attention. And good lesson for me. Pay attention, Mr. Morrow. Thank you, gentlemen. So it's between 2 and 3, but it's less than or equal to. I apologize greatly. And it's going from negative infinity all the way to 2 and 3/8. Questions, comments, concerns, problems, issues? Sir? No, because that's why I have a video. So if you couldn't keep up with that one, I'm sorry, but I got to continue with the video, sir. So make a little mark on your notes, and then you can go back to other problems. Thank you, sir. Okay, out, and that's it. That's it. Actually, I can because I'm done. What number did you need, buddy? I multiply by 15, the least common denominator. Yes, sir.
In this case, what you're going to do is 2 to 3 over 8. We have right to 3 over 8.
No, sir, you have to write 2 and 3 over 8. Yes, you can't just kind of like,
Oh, no, no.
no, you have to. You have to. Guys, math is exact. It's not kind of 2. No, it's 2 and 3/8. It's an exact thing. Oh, in the graph itself, yeah, I estimated that. But here in the interval notation, thank you, my brother. All right, look, I still got a little bit of time. So let's do another one. All right? How about this? Let's do, let's do one of these. Let's do one of these guys. 0.8x, let's say, plus, let's go, it's got to be a real ugly one, but so what? 2.4 equals, let's say, 3 is less than or equal to 3x, bless you, plus 8, bless you. Gonna be a real nasty one, and actually let's do it 0.8, and actually let's do this 0.03. Yeah, okay. Now we're cooking. All right, what do I gotta do here? What do I gotta do to get rid of these decimals, y'all? Multiply by 100 because I look at this guy right here. I got 2 decimal places, so let's multiply by 100. Fantastic. Okay. Everything is multiplied by 100. So this will become 8x, 80x, you're right. Thank you. Plus 240, less than or equal to 3x, plus 80. Now what, my brothers? We don't have any like terms to combine, but I subtract 3x to both sides. That's exactly accurate. Thank you. 77x plus 240 is less than or equal to 80. Subtract 240 to both sides. 77x equals negative 160. Very good, sir. Divided by 77. No. 0.8 times 100 is 80. Thank you for caring, though, bro. Hey, I make mistakes. We all do. Yes, sir. It's less than or equal to. Sorry, I'm so used to equations. And then this, to turn into an into a mixed number, remember, just divide it, guys. That's going to go in 2 times. And that's going to be 154 with 6 remainder. So x is less than or equal to 2, negative 2, and 6 77ths. That's why in the graph I don't make you exactly find the exact way. It's just an estimate there. Yes, sir. Yes, make these into a mixed number, please. And then my graph, that's between negative 2 and negative 3. It's about here, less than or equal to, so it's a bracket, shaded to the left. Interval notation, parentheses, negative infinity, to negative 2 and 6 77ths. Does that make sense, gentlemen? Thank you for an amazing class. Hope you learned a lot. Have a great day, and bye-bye. I made one little small error here, guys. Thank you for catching me. It is greater than, less than or equal to. Pay attention, Moro. It is a bracket. Thank you so very much. Once again, have a great day. Bye-bye.